Excavation will need to be planned very carefully. First, the geothermal tunnels should be dug and tubes placed. Then, the space for the structures can be removed and the excess dirt placed on top of those geothermal tunnels to get them to that ideal position of 12 to 15 feet under the ground. Moving on to the foundations, concrete will be minimized, but once it is poured, the wall framing can go up. The framed walls will be filled with hempcrete, a material that can be mixed on site or bought in pre-made blocks. We want to use it because it sequesters carbon, is fireproof and mold resistant, acts as a great insulator, can be done ourselves, regulates the interior humidity as it is vapor permeable, and as opposed to conventional builds that require many different layers and materials in each wall, hempcrete is made complete with a simple line render. The walls that are to be buried are like a basement, and basements can be built from treated lumber instead of exposed concrete. The framed walls will be a bit more complicated as they are underground. On the inside, a layer of rock wool against the treated plywood, followed by hempcrete, as the hempcrete needs some airflow on both sides, will make for a comfortable interior. On the other side of the plywood, the outside part, we'll have a water management system consisting of a waterproof membrane, some rock wool for the sand to push up against so that it doesn't interfere with the membrane, and drains at the bottom to take the water out and away from the walls. The green roof will be rather complicated as it requires many layers of insulation and waterproofing, along with expansion gaps and plenty of awkward curves and angles. It is purposefully designed to have a slope less than 10 degrees at all points so that the vegetation requires minimal anchoring, but the water and snowmelt can still drain away. As we shift our focus to the domes, notice that instead of the standard straight struts, these will be put together with a combination of bowed struts made from glulam cedar, locking into round plywood hubs. The plastic of choice for weatherproofing is EFTE because it has some elasticity and will last for at least 20 years. It's much more expensive than the standard greenhouse material of polyethylene, but that stuff only lasts for a few years. It's also clear as opposed to the cloudy polyethylene, so it lets in more light, including the UV spectrum, which is blocked by glass and polyethylene. 2 or 3 layers will be used with air blown in between to provide some insulation. For maintenance purposes, everything should be accessible from inside the dome using a lift. The clear plastic can be removed by taking a few screws out and releasing the thin strip of wood that is sandwiched between the glulam beam and the rubber seal with aluminum above holding everything together. To anchor the dome to the ground, a common approach is to dig a post hole, put in a wooden post, and add concrete. The problem is that the wood will rot out eventually, so to prevent this from happening, we can use an expanding foam option like this one to take the place of concrete. Some insulation should be used in between the underground dome posts to help prevent heat loss through the ground. The north side of the domes will be replaced with earth because the sun would never shine through that part of the dome to begin with, increasing our levels of energy efficiency. The resulting hills will be a good location for waterfalls when excess energy is being generated and to grow plants that like the incline and the more direct sun. While each dome will have the same type of structural systems, the potential variety of plant and animal life that can be supported will result in a wide range of ecosystems and environments not normally found in the northern climate zones.